Right, we're taking a look at scale ratio and scale factor. So our objectives for this video is we want to be able to determine the scale factor between two polygons. And then we also want to be able to apply the scale factor to find perimeter area or maybe even just a missing side of a similar polygon. So our definition, scale ratio, is just the ratio of the size of a model of an object to the size of the actual object. So maybe I have a little figurine of a dinosaur and the actual dinosaur might be 100 times bigger than that. So I might say like 100/1 is what I would have for my scale ratio. So it's just going to be a fraction. Scale factor is very similar. It's that same ratio, but it's basically just how much a shape is getting enlarged or reduced. And that's what we're trying to find there on that. We set it up with a colon in the middle of it. You'll see what it looks like here in just a second. So first things first here, we're going to find the scale factor between two polygons. So the way that we do that is we're just going to take our sides that are corresponding, and so we're going to set up our ratio. And so I could go ahead and I could do that all the way around here. So 4/1, I have 4.4/1.1, and so on and so forth. When I get my ratios, since I know that these are going to be similar to each other, then I've got those ratios all set. The way that we write it out for scale factor is it's whatever the left shape is, and then a colon, and then whatever the right shape is. So 4/1 is the easiest that we have for this. So I would just say that 4:1 is going to end up being my scale factor in this case here. So that's what I end up having for that. It's always going to be, if you have the left shape and it goes to a smaller shape there, you're scaling a shape down. If the right shape is going to be bigger, and so like the left shape is small and the right shape, if the left shape is small and the right shape is bigger, then it's going to be scaling up. So you're basically enlarging or reducing. All right. What is this going to look like if we're missing information? So say that we're trying to find the purple length of that rectangle there. So first things first is we want to take and find what our scale factor is. So 21/14 is just 3/2. That's my scale ratio. I could put my scale factor as 3/2 there, or 3:2. And so then what we're going to do is we're going to take and we're going to multiply by the scale factor. Well, in this case here, so on this, if you're going from smaller to bigger, so this rectangle is smaller and I'm going to the bigger one, you're going to multiply by that scale factor. So multiply by 3/2. So 8 times 3/2. When I do that, I just get it coming out to be 12. Now, when you do it with perimeter, perimeter is going to be the exact same thing. Now, you might be like, hey, and I already kind of started to write this out on here, but you might be able to be like, hey, I can just do Pythagorean theorem, find that missing hypotenuse, add them all together, and I get perimeter. It's even easier than that. So add up my sides on here, 3 plus 4 plus 5. When I do that, I get my perimeter comes out to be 12 inches. And so I'm trying to just find what my perimeter is for A. Well, first things first, determine the scale factor. So 16/4 comes to 4/1. So basically the left triangle is 4 times bigger than the right triangle. And then you're going to multiply or divide that perimeter by the scale factor. Well, I'm going from the smaller one to the bigger one. So I'm just going to take this and I'm going to multiply by 4/1, or multiply by that scale factor. So 12 times 4/1. And when I do that, I get 48 inches. And so that is going to be the perimeter of triangle A. All right, last but not least, scale factor with area. It's going to be very similar to it. So what I could do here is I've got 20/5, and when I do that, it should come out to be the same thing. So my scale factor is just 4:1 on this. And so what you're going to do is with area, you square the scale factor. So squaring the scale factor is kind of the other step. So 4 or 4/1, when I square it, basically 4 times 4 gives me 16. So now that I have that, what I'm going to do is I need to multiply or divide the area of one of the polygons. Well, I'm trying to find the area of triangle B. So in this case here, what's the area of triangle A? Well, 1/2 base times height, which that's just going to be 1/2 times the base is 12. The height is 16. So when I do that, I get that my area just comes out to end up being, what is that going to end up being, 96. So my area is 96. Now, I'm going from the bigger triangle to the smaller triangle. So basically, all I'm going to do is take this, and now instead of multiplying, I'm going to divide by that scale factor. So I'm going to divide by the squared scale factor. So divide by 16, and I get my area comes out to be 6 square inches.